Hello and welcome to this video. AP Brukers. Sorry if I mispronounce your name. I'm pretty bad with pronouncing names. But basically, I'm making this video to kind of respond to this email that you sent back to me. I'd like to say big thanks to the quick reply. I really appreciate it. Sorry ahead of time that it's taken me so long to respond. Had a pretty busy week, and I really wanted to read through everything that you said, and I checked out the tutorials by Ice Legase, sorry if I pronounced his name wrong, and went through that skin shader tutorial that you guys have on your site. And I've been really just experimenting with all different types of subsurface scattering and how you guys teach it, like your different types and other people's different types and my own version, and really try to bring them all together and trying to understand them just to make sure that I wasn't misreading anything. Now, I'm making this video to kind of show you my type of subsurface scattering technique and at the same time compare it to the different ones. I'm going to give a spoiler to the end of this video. I'm not trying to push my technique as better than somebody else's. It's just a different way that I find it's more artist friendly if you come from a Cinema 4D background. And at the same time, in the end, all the different types of results and techniques give the same exact effect in the end. So in the end, we all achieve the same result. We have just slightly different ways of getting there. So with all that out of the way, I'm making this video just to kind of explain all that, and I'm going to show 4 different types of subsurface scattering. We have volumetric lighting, then I'm going to show standard subsurface scattering through an object, creating like a gummy texture. Then I'm going to show an example of like a skin subsurface scattering and show you how I went through that tutorial and figured out how to make that skin from that link that you redirected me to, that really awesome skin texture created by Icelandic. I'm sorry if I pronounce his name. And I put my own little twist on it within my own technique just to kind of change it up a little bit to make it a little bit more original and something a little bit more than I made instead of just directly copying his. And then finally we'll end with a VDB example of how my technique works with VDV volumes, and I'll give a spoiler on that. I'm doing that just to point out how my technique does not work with VDB volumes. So it's not a be-all, end-all solution, but for certain types of subsurface scattering, it does work pretty well with that in my opinion. Again, too, I'm really making this video to kind of show that I would like to teach all types of subsurface scattering, just not my own technique. I'd be willing to teach and share all 3 of the different styles, and I actually, from looking at them, I feel like there's 3 different categorizations of subsurface scattering, different techniques, 3 dominant techniques that really kind of come down to it. But without further ado, instead of just talking about it, I'm just going to show the results right here. So let's start. Here's the 3 dominant techniques. We have a float, an RGB, and we have a Gaussian. And I called this recommended because this is what you guys have on your website for Cinema 4D right here. These are the values that you recommend for creating a volumetric lighting effect using the environment fog inside of an environment node. So right here we have, I'm going to turn this one off, turn this one on, start my Octane renderer, and if I select this tab right here, we have our environment. Here's the main right here, and here is the medium, and this is the medium that we put into that environment. And I made it black so you don't have anything in the scene, so it's very dark. And by default, this is what you get if you're trying to go for a volumetric kind of lighting effect. It needs a little bit more, I think, by default. I think the reason, though, I'm not knocking the artist by any means, it comes off this way. I think it's because it's supposed to have an actual HDRI in the background. That could have a thing to do with it. But if you're trying to make a black scene, which most people do when they're like trying to go for that volumetric lighting look, they want like a dark hazy spotlight or something kind of going for here. They want something a little bit more punchy. So I'm going to start from the bottom, and that would be the float texture, which is my technique behind it, the one that I've kind of worked out more. And then above that is the RGB, and this is the technique that you guys usually teach for most of your courses, throughout most of your courses. And it looks exactly the same. So my technique is by not any means any better. It's just slightly different. So what really makes them different is I'm going to hide this RGB. I'm going to turn my float environment fog on, and I'm going to drill down into the medium node here. And first things first is both of them I have set to a thickness of 100,000. whereas the recommended one says 324. So that is a difference right there. But I find a thickness of 100,000 and then a density of 0.001, as opposed to here where we have a density of 0.0001, is a little bit difference there. But way I counter this is I basically use a float texture in the scattering spot. And this is where my technique really has its main kind of the guts of it really, is I have a scattering value of a float texture instead of an RGB. Like they would, I still have that in my absorption. And the reason for this is because I want to be able to punch higher than 1. If I was an RGB value here, I'd be limited by a value of 1. Now this can very easily be fixed by simply upping my density. So I'll just take my density and back it up, and we'll add another 0, or remove a 0 I should say, and we've already fixed that to an extent. We can remove another one and we can bring it back to almost exactly where it was. Now in this case there's really no difference. We either have 2 zeros and a 1 and we crank this thing up to 50, or we leave it at 1, or a value of white that you would get from your RGB. So if we hide this and we hop into our RGB right here, we have a color of scattering with a value of 100% pure white. So we are limited on our scattering amount, but then we just lower our density. So we still can do this just by balancing out our color, our scattering, our absorption, and our density. Those 3 values combined with the 4th one, our thickness. Really no differences here. Now for me personally, I do not like too much the Gaussian spectrum for changing the colors as shown in this one here. It is very nice, and I understand how it works. And for some artists, this may be the direction they want to go to. They want to use a Gaussian spectrum to adjust the wavelength, width, and power. But I feel like for most artists, they need to have an actual visible representation for their color instead of a number, instead of dragging a slider to figure out what that color is going to be. To actually have a visible color is a big deal for most of them. But that said, I would still be willing to teach the Gaussian spectrum workflow in a subsurface scattering class if that's what you guys would like. And what I'll show next is, we'll hide this, is what I do like about mixing in part of a scattering and an absorption is if we use scattering and we're able to go above a value of 50 because we use a float texture. We're able to go above a value of 1, I should say. Sorry for that mix-up. It makes it easier because we have less jumping back and forth to do. Now, in this example here, we're not seeing too much of a difference. I'm going to be honest. This is just a preference in workflow. So I would really like to teach all these techniques, to have a video showing how to create different types of volumetric lighting and each different workflow type. I think would be very beneficial just to let people know there's different options and they could then choose which one works best for them. Because I'm a strong believer there's no one boot that fits all. Everybody has a different type of boot that they want to wear and use. So just provide all 3 different types of boots and let the consumer decide on which one they would like to use. But without further ado, let's hop into a real more tough example, and that is subsurface scattering right here. Now I already have a model prepared and it's a seashell 3D scan. I already have a texture created using this technique, but I want to point out this is where my technique really shines. This is where using the workflow I feel like I've developed a little bit more makes it much easier for creating subsurface scattering materials like this. So without further ado, let's make one from scratch. So I typically use a specular material. I'm just going to replace this, and we'll boot it up and we'll get it running. So the way my workflow would work is I'm just going to open up my node editor, and we'll kind of shrink everything down to about here, and I'm just going to pull everything up. So we have something to kind of work inside here. So what I recommend doing usually when I do this, whoops, I'll have everything more laid out if I ever do a course on this, is what I really feel, what I usually do and what makes this a lot easier if we use a float texture instead of an RGB is, we're not seeing that there, we add a scattering medium, And then, of course, we plug this into our medium slot. Now, of course, this is going to go black because we need to set an absorption value. So my typical setup is always going to use an RGB spectrum, like you guys really show, which is a great workflow. Always have that there. And I'm just going to set this to any color that I want. And this is the 3-step process. This is what a course that I really would love to teach on is subsurface scattering for objects specifically in a specular material, because this is extremely confusing when you first start out. So I would like to break everything down in a 3-step process where everybody could follow these 3 specific steps in this order and almost always get the effect that they're looking for. Step 1, attach your scattering medium. That's the first step. Step 2, or the true first step 1 I should say, is select your RGB spectrum. Pick what color you'd like it to be. Just go through and pick any color. Say we're going to make a nice kind of real strong orange color. Art direct that. Okay, we want it to be orange. Set that. Next, go to your scattering medium and adjust the density. I always like to take my volume step and set that to 0.5, and then simply drag your density until you have a density that looks about right for you. And for me, I'm liking something about this. So that's the value that you kind of want. That's the value you want to go for. Now, let's add our scattering. And for me personally, I like to add the scattering value to be a float instead of the standard RGB spectrum or Gaussian. And here's why. I'm going to plug this in, and I'm going to set my value to 1. This is as high as we could go if we did an RGB. I'm going to grab an RGB and set it right down here and set its value to 100% pure white. And if we plug this in, we're going to notice that there is absolutely no difference. Now, what is super nice is if we're using a float texture, or sorry, I'm going to plug that into here. There we go. If we use a float texture, we can punch in a value above 1. So I'm going to set a value of 25, which is going to be way too tense, maybe a value of 8, so like 8 times. Now we have a much more dense looking object. And what's super cool is we can now art direct the level of transparency through the object. That's what I really feel that the float texture gives you the ability. Instead of being locked at a value of 1 or white, see how we can still really see through this at a level of 1, and then we could bring this up to say, okay, level 3, and still can see through it pretty decent. Level 5, with 1 value, we can adjust how easily and clearly we see through this object as far as the scattering is concerned. Now, of course, we've already taken the work to go through our RGB spectrum and arc direct our absorption. We already went through and made sure we adjusted our density. So we're okay with being able to see through the shell there, but not through here. And then easily, we just keep adjusting this float texture until we get a density or a scattering value that looks about right for us. Now, what I really like is since we can go above 1 and we can keep going on infinitely as high as we want, I'll set like a value of 8. Say this is the look that you wanted. To achieve this same result with the RGB workflow, I'm going to unplug this. We'd first go through, set our RGB spectrum, say this is the one we want. Next, we'd plug in our RGB spectrum for our scattering, and we max out at white, and we're like, okay, this isn't quite what I wanted. I wanted it more dense. I wanted it more scattering. Well, okay, we can do that. We'll go to our scattering medium, and we must increase our density now. We have to go back and twiddle this a little bit more. Now we got our density up, but now it's just way too dark. The colors have just gotten way too much more saturated. So to counter this, we'd have to go back into RGB spectrum and go back here, and we'd have to pull this way back. I have to pull it up a little bit more. There we go, and now we're getting that result. But we had to jump back and forth quite a bit to actually achieve that. Now, if we were on our float texture and reversely we wanted it more dense, we could hop back into our RGB spectrum, and of course we could intensify the color even more to bring back that value. So I just feel like there's less hopping if we use a float texture. And now this is where I feel that it gets really powerful, is we can take our float texture and plug this directly into roughness so we have a value that's properly matching our roughness and our scattering. Because in real life, I mean, you guys probably already know this. I'm rambling about a bunch of stuff that probably doesn't matter as much. But in real life, if a surface is going to be more dense and have a lot more scattering going on, that means the interior is also going to be more dense. So if we have a surface, the outside exterior, if it's so rough and diffuse, it's going to make a very rough surface. It usually also has a very coarse interior that's going to allow for less light to pass directly through it. Meaning if we have a less rough surface, something that's very clear, it's going to have a very shiny surface here, very less rough, very smooth, and the interior is also going to be very smooth and have less roughness or scattering involved on the interior. So by having these both hooked up, we can very easily art direct our material in a single slider instead of hopping back and forth and back and forth. Instead of having to basically set our RGB spectrum up like this and then running that same thing into our roughness, we actually max our roughness out at white, which is okay and good, but then our interior value is going to throttle at white. Which was nice with the float is we could continue increasing the roughness and the scattering. Even though the roughness technically will throttle back at white, the scattering does not. So instead of working with RGB this point, say we want our interior more white, we're going to have to go back here, fiddle with our density. But the problem is, in the end, is that by working with our density, we're affecting our absorption and our scattering. By working with the scattering workflow with a float texture, we avoid affecting our absorption. Our absorption stays the same, we're just affecting our scattering. So in the end, we don't have to keep going back and forth to this absorption color and keep changing it, because in the end, we're not really changing it. If we work with a workflow with a float texture instead, we can keep increasing and decreasing the scattering going on inside of it without affecting our RGB spectrum. Now, it is going to make the color lighter. That's because there's so much scattering going on that that color is just kind of being eaten up. But technically, still at the same time, our color is not being affected here. So we're still keeping that color. So I think, in my opinion, it just has less jumping around. But again, this is up to personal workflow. Maybe for you, you prefer the reverse. So I'm rambling on a little bit about this. But in the end, I'm just trying to demonstrate that I know both workflows, and I'm willing to teach both of them in a course. Or if you guys would rather me not show the float texture workflow, that is also an option too. And now you're probably about to point out, though, this is all good and fine, but for a lot of people, there's a lot of things that people want to do with an RGB spectrum besides a black and white value. Maybe you want to have a scattering value of blue for some reason. Maybe that's what you want to do. There is a lot of reasons for that. And this does give you an effect that my technique just flat out does not cover, cannot do. Now, that said, here is the workflow I found that is, in my opinion, the real be-all, end-all kind of mix. You take your float texture, and you put it down here, then you take a multiply node, and we run our float into the bottom, and we take our RGB, and we run that into the top, and we plug this whole thing into scattering. Now, we have the ability to select a color, and we can intensify it beyond 1. So now we have the best of both worlds. We could put this up to like level 8. So now we get like a massive amount of scattering, and then we're going to have to dial our color back, but we have the best of both worlds. We have infinite height and depth ability, and we still get our color. So if we want to have no color and just have a straight kind of float value right here, we could just run this, and we can take the whole multiply and run it into the roughness to have a complete and easy workflow for adjusting our roughness and our specular all in the same line. It really is a pretty cool workflow in my opinion. But at the same time, I'm willing to teach whatever you guys would like. I'm just kind of showing off, or not really showing off, but just demonstrating that I do have those techniques down. Now, at the same time, we also could talk about, I would also talk about phase and emission when we're talking about volumes, but I love a value of like 0.6, and running that inside of here really just kind of adds a lot to this scene right here. Then we just simply grab our float value, and we'll just increase this a little bit more. Just a little bit, just to bring that up maybe to level 3. Yeah, just kind of darken that a little bit. And we can take our color. Actually, I'm not going to adjust this one. I'll just take our RGB, and I think a nice blue would be pretty good. And again, too, I know I'm rambling on a little bit on this, but again, too, what I really love about it is we can take our float at any time, pull it to 0, and it'll take our roughness down too at the same time, so we don't have to worry about hopping back and forth. And then we can set our color up. Say we'll get like a nice kind of light blue, and then we can set our density, because I wanted this a lot more dense. There we go, something like 180. And then all we have to do is turn back on our float texture, and our roughness is going to start coming back up again, and we can easily art direct this shell to get a look that we're going for. I really like that. That's a pretty cool look. But enough of me rambling on. Thank you for hanging in so much through all this. I'm going to stop this and move on to the skin shader and show the skin material that I developed, or not, I did not develop, skin material that I followed the tutorial on, I should say. And just to show that I did fall through it, and it was very interesting. I thank you for pointing that out. It was a very good, very interesting way of doing it. And it's super real skin, like what they show how to make in there. Like taking both values, taking your the specular material and then the diffuse material and mixing them together is really nice. And I changed it a little bit inside the mixed material. What I ended up doing, instead of using a Gaussian spectrum, I ended up switching it up, and I did that same thing that I just showed that I was doing. I changed it a little bit, but I did keep the absorption. And here is the other scattering that I could run into that. But there's the full setup, just to show you guys that I forgot to plug in the bump. But just to show you guys that I do kind of know a little. I did listen to you, and I did go through and did experiment with that and have played around with that. So I want to make sure that I'm not ignoring something else just because it's not my technique. I'm open to learning new ideas, trying new different ways of doing this. I feel like subsurface scattering is such a massive topic that I would just really love to teach it and make it much easier for other people to learn, because it was just super daunting when I first picked this up and tried to wrap my head around it. But here, of course, is that same material on this face right here. Kind of just showing how that looks right there. But again, this is really the same technique. And what I really love about setting up this float texture that we can then run into the roughness, which is level 1, is if we take the whole thing and plug it into our roughness, we can then art direct, just like that other material, the roughness and the specular all in one. And I'm going to take the float value for the mixer and set this to 0 instead of that. And we can see here's the raw specular going on, and I am going to unplug the bump. That's why I did that. And you can see we can art direct the skin look very easily by taking our float and just pulling it up. We can make it more rough, more transparent. Maybe you're going for a very interesting character, and bring this all the way up to, say, a value of 1. And what's really cool is the more we densify this, I guess that's a word, the darker it's going to get. So you can change your skin type really quickly depending on the look that you're going for. So if we bring this back to, say, a value of 0.3, we can change the color of our skin instantly by changing our level of scattering. And of course, we can change the colored scattering. So if I wanted to take this color of scattering like it shows in the course, we can just pump that right into there, and we're going to have that colored scattering value, which is really cool how that kind of works out. So we can, of course, take this whole thing, we're going to darken it even more, maybe even more. We'll set that to like go crazy, 50, and we can continually keep darkening that, and we're art directing this so lightly, and there's really little noise in it too, and without changing any color. I think the biggest thing that I'm trying to do with this workflow is limit down the hopping and the jumping from different parameters, because it really is a balance game of taking your density, your volume step, your absorption, and your scattering, and your phase, all these different things, which can be very overwhelming, and then balancing them all out, because as soon as you affect one, it changes the other. As soon as I touch my density, I'm affecting my absorption and my scattering. So by giving myself more control in the scattering, I can avoid hurting my absorption and my density. So I have two parameters now I don't have to touch. But again, I'm rambling on. This is just a little demonstration. I know this is getting a little long, but I'll stop this one here. And finally, let's talk about where my technique does just not work. And we are to that part of the video. And this is with VDB volumes. And here's a little texture that I put together for this smoke that I downloaded off the internet, a nice fire sim that someone made off of vdb.com. And it's pretty cool. It looks really good sim, and the texture turned out pretty good. I feel like I really do like how this one turned out. But I'm going to start from scratch and show you how I build it. So clear all this out. And what I do by default, like most people do, is just click fire, get all those default parameters thrown in there, just give us something to work with. First off, I like to take my volume step to 0.5 and my density, I'll start cranking up. So that's where I like to really, I want to point out is the workflow I would like to teach too for fire volumes. I would continue teaching the technique that you guys really show. I'm not going to change that whatsoever. I would just like to show my steps that I feel like that we can go through to really make creating fire volumes easier. All we have to do is grab this slider and we can just keep pulling it up and decide on the density level of our fire. Don't worry about the brightness. Don't worry about anything else. Just view the overall density of the smoke. Do we want very thin, light, wispy smoke, or do we want something a little bit more heavy? I want something a little bit more heavy. So I'm going to go for like a value of like 750 here, maybe 800, just till something feels right just for that part. Next, let's change our absorption. And realistically, I would have had them change this first. I like a value of 25% gray for dark smoke, which luckily that hasn't affected our density too much, so I'll leave that. Next up is the scattering. You cannot use a float, or you can use a float value, but the reason I don't recommend using a float value here is because you lose the ability to create color, and a lot of people like to have artistically colored smoke, so like maybe we can make like a bright green. And now we're getting a very interesting scattering effect for our smoke, which is pretty cool. But you cannot, normally what I would love to do is I would love to run a float texture inside a multiply node and then multiply that by the float inside that by the color like I showed in the other examples with the skin and with the other material, but you cannot put a multiply node inside of here. So in the end, I just feel that it's just better to run an RGB spectrum and just kind of work with that. So here I do agree that that is the better thing. So I do agree with you. It is real subjective when you use which technique and where. Sometimes it's just not available to use other techniques, so it's just better to use this one that is available. So for what I'm going for though, I want a nice 25% gray black smoke, kind of like something like this, something a little darker. There we go. And next up we have our, this is our scattering. I wanted this full white. I thought I was in absorption for a second. And we'll have full scattering, and we'll just leave that maxed. And now we finally come down to our emission and our emission ramp. So we're going to take our emission color or our emission value, power, and we're going to pull this back because we're just way too bright right now. And pull this down to something like this, something like 0.2, maybe a little brighter. And then we break this all down and we take our min-max value on our emission ramp. How bright is that going to be there? We're going to take this whole thing and pull this down. How is the transition between yellow and red going to happen and when? So I'd like the top of it, the most hot part, to be more yellow, like this, the real heavy part of the fire. I'm just going to pull this back a little bit more. Maybe that was a little too much. Yeah, something about right there. And then what we're going to do is we're going to take our, it's up here somewhere, scattering phase, and we're going to set this to a value of like 0.6, and this will just really kind of darken those edges on that fire. And I feel like that is pretty good. Now once I have all this done, the last thing I like to do is I like to take my volume step. We've been working at a value of 0.5, but once we have all this set, and we've been working pretty fast, then we can take this down to like 0.3. Or sorry, yeah, 0.3. That'll look pretty good. Then we'll go down to 0.1. That's what I meant to do. So then we take it to 0.1. Now it's going to get a little slower, a little bit more laggy because we're working with a much more high resolution volume step for our fire. But it looks way better. It just adds so much more detail to it. So that's why I do recommend starting at 0.5, edit all that up, and then drop it down, and then wham. Then you can really kind of finish that last touch-up. Beautiful rendering of VDB volumes inside of Octane. I just love it. It's just really nice. I want to get a nice faster GPU so I can make some animations with this. But that is basically it. Then we can just take our power and pull this up or lower. I know you guys don't need me to teach you this. You guys already know all this and probably most likely way better than I do. But I'm just showing you all these techniques to show that I am aware of these different techniques, and that I would I'm capable of teaching them. Well, maybe I'm capable of teaching them. Maybe you guys went through this and like, this guy's not capable of teaching this stuff at all. But I hope that you feel that I'm capable of teaching this stuff here. And I would love to teach them. I really like to teach, and I would like to teach these new courses on your website or wherever you'd like to place them, and show other students how to create these subsurface scattering effects, because a lot of it is documented but not in video form, and it's very hard to follow through and figure it out for the first time. To have somebody to talk you through it, I think really adds a lot more. So to keep the documentation would be fine. Like, absolutely agree with it, keep the documentation, but maybe add a video with those. So that's what I'm really trying to sell in all this. But in the end, if you guys decide you would rather not, I fully understand that. I'm going to stop this because it's slowing my computer down a little bit. But if you guys decide that rather not have me go through and teach this, then I fully understand that. And I read too that you guys are going with the CPD plugin. You've recently tapped into your pool of artists at Octane. Otoy, and we are currently coordinating with our Los Angeles HQ and deploying some manpower for the purpose of creating videos for several plugin additions, not limited to Cinema 4D. All our videos and tutorials are provided freely at this time. Members of our own team in LA are keeping up with the latest development of the Cinema 4D plugin and Maya. I would love to. I don't know if I'm part of that group, but I would love to help out and be part of that movement to help create and teach more courses for Octane, because I feel like it is a really powerful tool, and I feel like subsurface scattering particularly is rather under-documented, and nothing against what you guys have done there. I know you guys are doing really doing a great job. Like, Octane is an awesome program, but I just feel like some of the documentation there are presented poorly and gives a bad representation of what Octane is capable of. When I first tried to learn about subsurface scattering, I felt that Octane was just bad at doing subsurface scattering by the examples I saw, like in some of the areas, not all of them, but some of them. And I felt that, oh, Octane must just not be good at doing subsurface scattering. But I played around with it for a few days, and I started to get some really good results. And I was like, man, Octane does some beautiful subsurface scattering, just gorgeous. Like, not very bad at all. I loved it. And I just feel like it could maybe be presented a little bit more nicer. But that's just my opinion, of course. And it's still, you guys have a very good setup still, I have to say, for what you're putting out there. And your last question here was, having mentioned above, your most immediate need is actually tutorials for Octane in SketchUp. And I'm afraid I do not use SketchUp. I played around with it a bit, but I just do not use it very much. So I'm afraid I couldn't teach a course on Octane for SketchUp. But thank you guys for asking about that. I do appreciate that. And I know this video has become extremely long, and I'm very sorry about that. And if you guys have watched through it to this point, I really appreciate it. And I want to let you guys know, whatever your decision is, even if it's no, if it is no, I'm going to move on, and I'm going to just create my own training tutorial series. And there'll still be Octane training out there, so you guys are not going to lose my support if you decide against that. So either way, I'm sticking with Octane, and I'm going to be teaching. So I just wanted to let you guys know, though, I want to give you guys the first shot if you wanted me to teach a course on this or not. But thank you guys so much for listening to my ramble through all this. I really do appreciate it. I appreciate you taking the time. I know you guys are really busy, and I thank you so much for listening to what I had to say. So I will talk to you guys later. Thanks again.